In this tutorial we are going to look at the Monte Carlo sampling algorithm to solve the same reliability problem as we solved in the previous tutorial with form. So the functional expression that you can see here is the same thing as we used earlier. So we're asking the probability that this expression, in fact these two terms inside the parentheses, are greater than the value 1. So that is the threshold in the limit state function. In the analysis methods, I'm going to make use of the orchestrating algorithm, the analyzer as we call it in art, that carries out sampling analysis. So here's the orchestrating algorithm for sampling analysis, and I see that the accumulator, namely how the points or the samples are being processed, they are being processed by the failure probability accumulator. So that's the one that I want to use, and I have a look at it right here. This is the failure probability accumulator, and I see that 1 million samples is kind of given here as the maximum number of samples, and a target coefficient of variation of 5%. Now I'd like to show you how to change these parameters at runtime. So I'm going to change this target coefficient of variation to something very small, so that the analysis will run, and in fact it'll run for quite a long time, and I'll show you how you can change those parameters while the analysis runs. So having set those analysis tools, and all of this, all the other tools are given in the input file that I gave in a previous tutorial, I'm ready to go to analysis, run analysis, and select the sampling algorithm as the orchestrating algorithm, and I press OK. So what you see here while the analysis runs, you see the number of samples along the horizontal axis, and you see the coefficient of variation that's now approaching zero, but quite slowly. You can see how that coefficient of variation goes down as the analysis runs. And you can change this, in fact you can change a number of things to make the analysis go faster by changing the frequency at which the output is plotted, but also I can go back here and change the target coefficient of variation to 5%, and when I press enter, the analysis stops because we already had gone below 5% coefficient of variation. In fact, we see here that the reliability index here, the generalized reliability index from this mean-centered Monte Carlo analysis, is a little over 1.8, corresponding failure probability, and here the coefficient of variation is around 1.2%. So these are the results from the Monte Carlo sampling analysis.